Try to imagine that every star, planet, galaxy, and living thing ever seen by human eyes amounts to just 5% of the entire cosmos. The vast majority of our universe is dominated by something we can't see. It is a massive, silent presence that permeates space, yet it has never been caught on camera or touched by our instruments. What is this matter, and why does it refuse to reveal itself? Astronomers first realized the universe was hiding something when they measured how galaxies rotate. Based on the amount of visible stars and gas, these galaxies are spinning so fast that the laws of gravity should have caused them to tear themselves apart eons ago. The stars at the edges should be flinging off into the darkness. Instead, these galaxies stay perfectly intact. They behave as if they are weighed down by a massive amount of invisible material, providing the extra gravitational pull required to keep every star in its orbit. In the 1930s, Swiss astronomer Fritz Zwicky noticed this same effect in massive galaxy clusters. He calculated that the clusters were moving far too quickly to be held together by visible light alone. Decades later, Vera Rubin confirmed these findings by observing the rotation of individual spiral galaxies. Her data showed that regardless of how far a star was from the center, it moved at a high, constant speed, proving that galaxies contain significantly more mass than we can see. We have never seen dark matter directly. We know it exists because we can measure the immense gravitational effect it has on the visible stars and galaxies around it. Dark matter is defined by what it doesn't do. It does not emit, reflect, or absorb light. Because it has no interaction with the electromagnetic spectrum, it is completely invisible to every telescope ever built. This chart shows how the universe is put together. Atoms make up just 5%. Dark matter accounts for 27%. The remaining 68% is dark energy. While dark matter's gravity pulls structures together, dark energy drives the universe's accelerating expansion. Dark matter forms massive, invisible halos around galaxies. These halos act as a cosmic scaffold, a structural web allowing galaxies to form and remain stable. The architecture of the entire universe is built upon a skeleton that we cannot see. We detect this invisible mass through gravitational lensing. When light from a distant galaxy passes through dark matter, extreme gravity bends the light's path. To an observer on Earth, the distant galaxy appears distorted, as if seen through a massive magnifying glass. We see this clearly in the Bullet cluster. When two galaxy clusters collided, the normal gas, shown in pink, slowed down as it crashed together, but the dark matter, mapped in blue, kept moving forward as if nothing had happened. Further evidence exists in the cosmic microwave background, the oldest light in the universe. The temperature patterns in this map only match our observations if a large amount of dark matter was present just after the Big Bang. These independent observations, from the way light bends to the heat of the early universe, all lead to the same conclusion. There is a vast amount of matter we have yet to identify. To find it, physicists are looking for new subatomic particles. The leading candidates are WIMPs, along with axions and sterile neutrinos. To catch these particles, researchers have built sensitive detectors deep underground in isolated mines. These locations shield the experiments from cosmic rays, allowing scientists to wait for a single rare collision between dark matter and an ordinary atom. Other experiments use particle accelerators to smash atoms together at nearly the speed of light, hoping the high energy will produce dark matter particles directly in the lab. Despite these massive efforts over several decades, we have not yet detected a single dark matter particle. Some scientists suggest that dark matter might not be a substance at all. A theory called modified Newtonian dynamics proposes that our understanding of gravity is flawed over very long distances, and that we are seeing the effects of gravity changing, not invisible matter. While modified gravity offers a different mathematical approach, it struggles to explain the physical mass distributions seen in cluster collisions. Most evidence suggests a substance is physically there, even if we cannot see it. Today, dark matter remains one of the largest gaps in our understanding of physics. Its role is vital. Without the gravity provided by this hidden mass, stars would never have gathered into galaxies, and the conditions for life to evolve would never have existed. It is a strange realization that everything we have learned about the stars is secondary to a presence we cannot see. We have spent our history studying the light of the universe, while an invisible presence has shaped the cosmos from the beginning. If you want to keep exploring the mysteries of our universe, subscribe for more deep dive documentaries on space, cosmology, and the secrets of the cosmos. We are built from the visible atoms of the universe, but our fate is tied to the shadows.